Hey there, it's Math 116, section 1.3. This is linear equations, looking at the equation of a line. So I wanted to show you a couple of different things that we look at when looking at linear equations. The first thing is how to write the equation of a line when you have a point and a slope. So here is an example. We have a slope equal to -5 and a point 0, 2. And this is number 29 on page 86. So the equation of a line, there's a lot of ways you can write it, but basically you want y equals, this is the classic way, mx plus b, where these are numbers. But really anytime you have a y and x and they're just single, they're to the power of 1, and then a constant, that is the equation of a line. So we have a slope and a point, and we're going to use this one called the point-slope form. This is kind of a nice version of how to write the equation of a line. You write it like this: y minus y1 equals m, that's the slope, times x minus x1, where you have this point y1, x1. So I'm going to show you how to use this point-slope form, so called because it uses a point and the slope. So we have our point, we have a slope, sounds like the point-slope form to me. So here's the equation, y, that stays as a y, minus y1, so it's right there, 0, now this will be nice, equals m, -5, it's the slope, times x minus x1, so the point of x there is 2, and now we simplify. Y equals -5x, and distributing the 5 there, -5 times -2 is plus 10. So that is our equation. Isn't that point-slope form nice? So the next part says graph it. It says write the equation and graph it. So I'm going to graph it using this fancy graphing app. I found another graphing app. And so here it is. We have y equals -5x. Look at it. Do you see how it does that thing? Plus, it's going to change it, 10. There it is. So I'll just kind of click on it like this. So there's the equation, -5x plus 10. I can zoom in if you like. Most of you, it's going to look more like this. So you got this point 2, 0, and a point up here, 0, 10. Isn't that nice? That's Desmos.com calculator. Yeah, excellent. Okay, so let's do another one. Problem, we were using the point-slope form, but suppose you don't have the slope. Suppose you only have 2 points. So this is question number 35. You're given 2 points, 3, 2, and -1, -6. Well, 2 points are all you need. Anytime you have 2 points, you can draw a line between them. I personally can't really draw a straight line, so I'm going to use one thing. See? Wasn't that a great illustration? Do you understand? Okay, so in order to use our point-slope form, first we have to find the slope. So the first thing to do here, when you have 2 points, is to first calculate the slope of the line. So the slope is rise over run. And in this case, you take y2 minus y1 divided by x2 minus x1. It doesn't really matter which point you call 1 and which point you call 2. I'll just call this one 1 and this one 2, but if you can reverse them, it's fine. It's the same line if you go from this point to this point as that point to that point. So y2 is here, -6 minus 2, so I'm taking this one minus that one. x2 is here, -1 minus 3. That noise you hear is Leo drinking from his water bottle like a big gerbil. So we have -6 minus 2, that's -8, and look what happens. Hooray! I like it when the negatives cancel. So -8 divided by -4 is +2. So we have the slope is +2. So if you're given 2 points, that's how you find the slope. You take rise over run and do y2 minus y1, x2 minus x1 gives you the slope. And now we're back to our point-slope equation. Remember y minus y1. I'm going to use that same point-slope form that I used in the previous problem. I'm noticing, and again, it doesn't matter which point you choose. I'll choose this point, y minus, I plug in the value of y1, which is 2, equals m, that's the slope, we just found that, 2, times x, that just stays as an x. You need to leave one x and one y in there. And x2, it says x2, it's just, I should have said x1, 3. So whichever y you're using, make sure you use the same x. So this is all 1 point right there. These guys are 1 point. So now we simplify. Y minus 2 equals 2x minus 6. So I add 2 to both sides, and I get y equals 2x plus minus, sorry, scratch that out, minus 4. 2x minus 4. If you'd used the other point, you would have gotten the same thing. Suppose you decided, I want to use the point slope form, but I'm going to use this point. You would have said y minus y1 equals m2 times x minus x1's negative 1. That would have been y plus 6 equals 2x plus 1, like that. So you had y plus 6 equals 2x plus 2. Subtract 6 from both sides, and you would have had y minus 6 minus 4. So it doesn't matter which point you use. So here's the equation. Let's graph it. 2x minus 4. Back to our fancy app. Y equals 2x minus 4. Why is it doing that? Oh, because that's a minus. See? There you go. I'll get rid of that one. Ta-da! I'll zoom out a little bit. And I'll zoom in! Give you vertigo from this problem. So yours will look something like this. It's got a point there, 2, 0. Point up here. The nice thing about this program is you can just click. I'm using my mouse. I'm just clicking on points on the line. And again, that's Desmos.com. I just clicked it because it said free online calculator, and I was curious. So there you go. Okay, I'm going to show you one more of these problems, how to work a story problem to get the equation of a line in a story problem, or a word problem, or an application is what they like to call them these days. So here's an application of linear equations. This is question number 55, residential electric costs. So an electric utility company determines the monthly bill by adding an energy charge. So they add 8.38 cents, this is important, per kilowatt hour to its base charge of 16.37 per month. So if you let y equal your monthly charge, they're saying, the question asks you to write an equation for the monthly charge y in terms of x. So your monthly charge is going to be y, and x is going to be the number of kilowatt hours used. Number of kilowatt hours. Kilowatt hours. How's that for fancy? Kilowatt hours used. So the way the electric company is calculating your bill, they're saying y is, we're going to have this base charge of $16.37. They're going to charge you in dollars. Plus, they're going to go out and measure how much energy you used. So x times, and they're going to multiply that by this rate, which is 8.38 cents, but we have to change it to dollars, so it's $0.0838. Everything has to be in terms of dollars because you're being charged by dollars. So it looks like this. So I could rewrite it, but basically it's 0.0838 times the amount of kilowatt hours you used plus $16.37. Even if you use no electricity, you turn everything off and leave for the month, you're still getting that charge of $16.37. So this is what they mean. This is how you would write it. Ta 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 ta. Okay. Good job, everybody.